This video, we're going to be adding and subtracting rational expressions, specifically ones that have a common denominator. Then we're going to look at how to find the least common denominator. So we're going to start by just looking at how do you add and subtract rational expressions if they have a common denominator. And so in these, we can see that the denominator is the same. And so when that happens, you simply add or subtract the numerators. The denominator is going to stay the same. It's not going to change. So let's look at some examples. So in example 1, we can see that our denominator is the same. So what that means is I'm just going to add or subtract. In this case, I'm subtracting. And I'm going to put that over that common denominator. And then I'm going to simplify. So 5p minus 15p is going to leave me with negative 10p over my common denominator. Then I can simplify just as we know how to simplify rationals. So anything that's common can cancel. So those p's, you know what? That's not a p in the denominator. I accidentally wrote p. That should be a q. I apologize. P's and q's are difficult when they're in the same problem. So I can, though, simplify the negative 10 and the 16. I can take a 2 out of both of those. So that would become a negative 5, and that would become 8. So final answer would be negative 5p and 8q. All right, here again, my denominator is the same. So I'm going to add my numerators, and I'm going to keep that denominator. Then I'm just going to clean that up. So 6 and 2 I can combine. Keep that denominator. If I could simplify, I would, but I can't simplify anything here, so we're just going to stop. Right. Example 3. Again, my denominators are the same. So I'm going to combine x squared minus 7x plus 10 over x minus 5. Now, we always want to try to simplify. In this case, I have x squared minus 7x plus 10 in my numerator, so I can try to simplify that, meaning I can try to factor it. So that's going to factor into x minus 5 times x minus 2. And then I've got x minus 5 in the denominator. So what can happen here? Well, this matches with this. That's a common factor. So that means the only thing I have left is x minus 2. Okay. Example 4. Again, my denominators are the same. So I'm going to keep that denominator. Going to combine these. 4y squared minus 4y. Try to simplify if we can. So I'm going to take out a GCF. That leaves me with y minus 1. I can see that those do cancel. And so my final answer would be 4y. Okay, let's look at how to find a least common denominator, because not always will you have the same denominator, and so you will have to find that. So if you're trying to add or subtract rational expressions that do have different denominators, then what you're going to have to be able to do is to change them, right? You're going to have to change them so that they are equivalent. And that's called a common denominator. And that involves finding the least common denominator of the two original expressions. So the first step is to factor. There's a lot of factoring involved here. So we're going to factor the denominators completely. Notice I said factor the denominators. That's all we're focused on. The next step is the least common denominator. We're going to call that the LCD, is the product, remember product is multiplication, of all unique factors that we found in step 1. Each of them is going to be raised to a power equal to the greatest number of times that factor appears in any one factor denominator. Okay? So it sounds a lot worse than it is. Let me show you what I mean. So for example, if these were our fractions and we wanted to find the LCD, and I'm just looking at the denominators. So my denominators are 9 and 15. So start with 9. I want to list out the prime factors. Remember, prime means you can't break it down anymore, right? Only be multiplied by 1 in itself. So I could write 9 as 3 times 3. Okay, well, that's the same thing as saying 3 squared. That's that exponent I was talking about. Okay, 15. I can write 15 as 3 times 5. So the LCD is going to be the product of all the unique factors, each raised to a power equal to the greatest number of times that factor appears. So that means that 3 and 5 are my unique factors. Well, I boxed in that first 3 because that had a square. That's the greatest number of times that factor appeared. And then 5 only appeared that once. So the LCD of 9 and 15 would be 3 squared times 5, or 45. Okay. All right, let's look at finding the LCD for this one. So you've got 6x cubed and 8x to the 5th. So let's look at 6x cubed. Okay, we'll start with 6. So 6 would be 2 times 3. And then x is just x power of 3. Okay, then 8. X to the 5th. Okay, well, 8 is 2 times 2 times 2. So that's 2 to the 3rd. And then x to the 5th. So I need all of my unique factors. Okay, well, they have to have a 2, right? It has to have a 2. And that 3 is my highest exponent. So that means that my LCD has got to have a 2 to the 3rd. Okay, it also has to have a 3. Well, that's the highest exponent because that's the only one. It has to have an x. And 5 is the highest exponent for x. So what that means is my LCD is 2 to the 3rd times 3, so 24, x to the 5th. Okay, so now, what if we have something like this? Okay, well, let's start with 6y. Prime factors of 6y. Okay, well, 6 would be 2 times 3 times y. All right, 4y plus 12, okay. Well, 4y plus 12, I can take out a GCF, which is 4, leaves me with y plus 3. Okay, well, I can break 4 down. 4 is 2 squared and y plus 3. Okay, so my LCD. My LCD has got to have everything. That's what the common part is. So I know it's got to have a 2. I'm going with this one because it's 2 squared. I know it's got to have a 3. Well, that's the only 3. I know it's got to have a y. That's the only y. And I know it's got to have a y plus 3. That's the only y plus 3. So do you see how I went through and just picked everything? Everything's got to be there. So that leaves me with 12y y plus 3. Okay. All right. So we got to factor these. Okay. So x squared plus 4x plus 3. So that factors into x plus 3 and x plus 1. Okay. X squared plus 10x plus 21. That factors into x plus 3 and x plus 7. Now my LCD, I have to make sure I include everything. Notice they both have an x plus 3. Okay, great. That just means it's got to be there. Neither one of them have an exponent of anything, so I just know I need an x plus 3 in my LCD. Okay. Well, I know it's got to have an x plus 1. That check, I already put that there. Also, I need that. It's got everything. Okay. All right, how about this one? Again, we're going to factor. Every time we're going to start by factoring the denominator. So 5x squared minus 5. So that's going to take out a 5. Leaves me with x squared minus 1. Can keep factoring that. 5, x plus 1, x minus 1. All right, so that one's factored. Now let's look at the next one. Needed to multiply to 1, but add to negative 2. Okay, so that's x minus 1, x minus 1. Oh, okay, I could write that as x minus 1 squared. All right, so LCD. I know it's got to have a 5. I know it's got to have an x plus 1. I know it's got to have an x minus 1. Hey, but look, I've got x minus 1 to the second power. That means that it has to have that because that's the biggest power. So in this one, here we go with that same thing, but different signs. Both of those denominators are already factored out. They're just opposites of each other. So we could use either one of those as the LCD because really it's just a difference of a negative 1. And you'll see how we're going to use the LCD in the next video. This is just focusing on finding it.